Hi, my name is Dr. Andrew Sommers. I'm a faculty member here in the Department of Mechanical and Manufacturing Engineering at Miami. I'm going to talk to you a little bit about a project I was working on this past year. And our project was focused on improving the efficiency of heat exchangers, specifically heat exchangers that would be used in HVAC and R applications. What I have here is a cutaway view of a window air conditioning unit, what we would call an evaporator. The air side is typically the most inefficient part of the heat exchanger. And in an air cooling application like air conditioners and refrigerators, the air, as it's moved through the heat exchanger, you get the water to condense out onto the heat exchanger surface. And that water on a compact geometry like this doesn't drain very readily. And the water, as it's retained on the heat exchanger surface, can be problematic for a number of reasons. It can decrease the heat transfer performance of the actual unit. That water is now occupying surface area that otherwise would be more readily available for heat exchange. The pressure drop across the heat exchanger generally goes up. You now have to, your fan has to work harder to move the same amount of air through the heat exchanger. And then the retention of water on the heat exchanger can also lead to bacterial growth, biological activity, and Legionella bacteria is one that often is associated with wet, dirty heat exchangers. So our work was aimed at trying to more efficiently drain water, condensate from the heat exchanger in an effort to improve these three things. And so the surfaces we looked at in this project are engineered. We have a couple different patterns here. This is a laser etched surface where we have a linear pattern, and the surface has been engineered with regions of different wettability. And so we have actually created a surface tension gradient on the surface so that water is naturally, there's an affinity for water in certain places on the surface. You can actually pull water to particular locations, what I would liken to like a gutter on a roof. You can create micro gutters on the surface and try to get water to collect in these regions you know would be more easily, where the water could be more easily removed. And so this surface was laser etched. We're just modifying the roughness here of the surface. In some cases we looked at applying coatings as well. Here's a radial pattern, again a surface tension gradient where water is pulled towards the center, and then hopefully as that water is pulled towards the center, all the small droplets coalesce and you can get the water to be easily removed from the surface. So this was some of the different surfaces that we looked at in the project. It was a 12-month, one-year effort. And happy to say the project is finished well, and we're in the process of trying to write up those results.